Hi, welcome back to our YouTube video on the ETAP series. In today's video, we shall be modeling all these components that we've selected based on this single line diagram. So let's start. So we'll start with the grid. You double click on the grid, name it, then you go to rating. So what is rated kV here? The rated kV is 33 kV. So you select balance and the megawatts of the grid, say 100 megawatts. So you click on OK. So we've not set the 100 the short circuit rating of the grid. So you come back to, you double click on the grid, then come to short circuit, then it will ask, this is short circuit rating, it is in MVA short circuit. So if it's a three-phase system, which we are working on a three-phase system, so you select, you put the 100 MVA short circuit. In this case, I'm going to use 100 MVA. Ordinarily, all this information will be provided by the transmission company or wherever the grid is coming from. So you have to get this MVA short circuit from the utility company. So you click on OK, but in this case we assume it is 100 MVA short circuit. So you click on OK. Now automatically this bus, it has tapped this rated kV from the grid. So that's why you are seeing bus 1 as 33 kV. So the bus voltage on this the voltage on this bus is 33 kV automatically. So we now have so we don't need to model this bus anymore. So since it has automatically sees the voltage from the grid, so it has started from it. So we now try to modify this transformer T1. So you double click on it, then this is the ID, so we still remain like we still maintain that T1. Then you select the standard. If you are using if you want to use ANSI, you can use it, or if you want to use IEC, but in the case of Nigeria we use IEC, so we maintain this IEC. Then the condition of the transformer, is it in or out, in the sense that is it in service or it is out of service. So definitely it is in service, so you select the in service. So the connection, if you want to select the type of coil, if it is short type, if it is core 3 limb, if it's core 4 limb, core 5 limb, single phase. So but in this case we are going to select shell, so we'll maintain that. Then you go to rating of the transformer. So the secondary voltage is 11, so we are going to select 11 based on our single line diagram. You have 33 stroke 11 kV. So automatically the primary side of the transformer is connected to 33 kV bus, so it will automatically select the bus voltage for the primary side. So we are going to select automatically it has selected that 33. Then you input the secondary voltage, which is 11 kV. So the power rating of the transformer is, according to the single line diagram that I want to use, is 15 MVA. So you put 15, then press tap. So one of the good feature of ETAP is it will automatically generate some parameters for you that you don't even need to compute for any. The computation time will be minimal anyway. So if you can check, if you check before we input the MVA rating of the power transformer, this FLA is at 0, and the secondary side is at 0. So what this is trying to say is the full load current at the primary side of a 15 MVA transformer is 262.4 amps. At the secondary side is 787.3 amps. So from the definition of the transformer, transformer transforms electrical power from one level to another, like voltage and current from one level to another without changing its operating frequency. So whatever the changes that a transformer is performing, the power will still remain the same, in the sense that if you multiply 33,000 by 262.4, it will give you 15 MVA. If you multiply 11,000 by 787.3, it will still give you 15 MVA. So I think we should be okay with that. So MVA Z base is still 15 MVA. So bus nominal voltage is 93. I think, okay, let's try to set the impedance. If you have the nameplate of the transformer, you have to input the percentage impedance of the transformer, the X over R over X, and the X percentage, R percentage. So, but in this case, we don't have the data. So, and one of the key features of ETAP, or let me say the good side of ETAP, is based on the rating that you've input, it can automatically generate a typical Z percentage, X over R, R over X percentage, X percentage, R percentage. So in this case, we are going to select a typical typical Z and X over R. So by selecting this, it will automatically generate all these parameters. Alright, so you go to this side as well, then click on, okay, this is the no load test data used for unbalanced load flow. So we are working on balanced load, so we don't actually need to input for this. Alright, so you click on, okay, so let's try to, if you want to change the type of a power transformer, probably after conducting your load flow, you discover that the voltage at the primary side, at the secondary side of the transformer is low, so you may want to tap it down or up depending on the problem you are experiencing. Maybe you are experiencing low voltage or high voltage. So this is where you tap your power transformer. So we have this here. So this is where we set the vector group. So vector group is nothing but the phase shift between the primary and secondary. Probably in another video we may try to discuss further on that. So basically in Nigeria, the vector group for a power transformer, according to Nigerian Electricity Supply Industry Standard NESIS 2015, the vector group for distribution power transformer is DYN1. So in this case, the ETAP has automatically selected the vector group for us. So if you might want to change it, like probably you have another vector group. Let's say for the power transformer you want to model is DYN11. So from the phase shift between primary and secondary for a DYN1 is 30 degrees. The phase shift between primary and secondary winding of a DYN111 is 30 degrees. So for for dyn1 rather, for dyn11 is minus 30 degrees. So if you select minus 30 degree here, it will automatically change this vector group to 11. So I think we get that. So that's how to change the vector group. So you have to know the phase shifts between the primary and secondary, the degree. So this is the phase angle. So we select 30. If you select 30, it will change it back to dyn1. So the primary side of our the internal connection of the primary side of the transformer is delta. So this is a sign of a delta. So if I want to change it, you click on it, then it will change to star. So you select whether it is what type of grounding is it. Is it an open grounding or solid grounding, resistor, reactor, transformer resistor, transformer reactor. But in this case, the primary winding, according to our single line diagram, is dy. Okay, there should be one here. So dyn1. So you select delta, then the secondary side is star. So and you maintain the grounding to be solid type. So click on OK. I think we should be okay with the. I think we are done with the modeling. Let me see. These are not actually peculiar to what we want to do right now. So alright, so the next thing, if you try to check this bus 2 now, since we modeled this transformer to be 33/11, automatically the 11 kV secondary voltage of the transformer has been automatically adopted by the bus 2. So that's why we are having bus 2 as, let me try to zoom it. Okay, that's why we are having bus 2 to be 11 kV. So remain this LV cable, so which is 500 XLPE cable. So if you want to select cable, it is important that you understand the larger the current, the larger the cross-sectional area of the cable. So for 700 and something amps, which you may not operate the transformer at full load, so you will not you will not load the transformer 100%. So if you use 500 for such load, I think it should work. So let's try to model this. Okay, the cable we selected for this single line diagram is a 500 XLPE cable. So let's try to model this cable. So you double click on the cable just as we've been double clicking for other components. Then you go to cable 1. Let's still maintain this cable 1. So it taps from bus 3, which is 11 kV, to bus 2, which is 11 kV as well. So this cable is 11 kV rated. So you put the meter, the length of the cable, let's say, okay, from the secondary side of the transformer to the bus, let's say 10 meter. Okay, let's say 5 meter. So then you click on, okay, the condition of the cable, is it in service or out service? So out of service. So the cable is still in service now. So select, then the number of conductor or per phase. So since let's use this 1. So you go to library if you want to select types of